Molecular and ionic compounds in chemical reactions have to do with electrons that can be gained, lost, or shared. So the gain or the loss of electrons results in the formation of ions. And I believe we've talked about this a bit already before. So here we have a neutral sodium atom. It has 11 protons and 11 electrons. And this is in figure A here. After it loses one electron, it becomes a sodium cation with 11 protons and only 10 electrons. And this loss creates a positive charge since now there's more protons than electrons. So we have 11 protons, 10 electrons. That's one more proton than electrons. We subtract that difference. That gives us our Na plus there. Predicting ion charge, we can use the periodic table to predict charges of the main group elements when they become ions. So for example, the group 1 metals lose one electron and they will form a 1 plus charge, or plus ions, or +1 ions. Group 2 metals lose 2 electrons and they can form 2 plus ions. These elements, they tend to lose just enough electrons to match the electron configuration of the nearest noble gas. We can also predict the ion charge for nonmetals as well. For group 17 elements, if they gain one electron, then they form an anion with a -1 charge. For group 16 elements, if they gain 2 electrons, they form an anion with a -2 charge. Calcium is in group 2. It has 20 protons and 20 electrons. When it loses 2 electrons, it becomes calcium 2 plus. Now it has the same number of electrons as argon does. Let's take a look at that on the periodic table. So first we'll need to find calcium on the periodic table. Here's calcium. And if it loses 2 electrons, then that means that it's going to have the same amount of electrons as argon when argon is in its stable state. So argon has 18 protons. It has an AMU of about 40. So we can, just doing some quick review here, we can figure out the number of neutrons that argon has. So its atomic mass, protons plus neutrons, is 40. We can subtract 18 protons, and that gives us 22 neutrons that argon has. But more importantly, related to the ions, predicting the ionic charges, is that it has 18 protons. It also has 18 electrons. So if we go back to calcium, calcium has 20 protons and 20 electrons. If calcium loses 2 electrons, now it has 18 electrons, or the same amount as argon. Because it's lost those 2 electrons, but it still has the 20 protons. Now there are 20 protons and 18 electrons, giving it a calcium Ca2 plus ion. So it'll become a calcium 2 plus ion with a +2 charge. Bromine is in group 17, and it has 35 electrons and 35 protons. Let's see what happens if it gains an electron. So first we'll find bromine. Here's bromine. It has 35 protons, and that means it must have 35 electrons in its stable state. If it gains an electron, it becomes bromine, or bromine -1, or Br negative. And if it gains an electron, then that means that This is going to be, it's going to match the electron configuration of krypton. So if it's gaining an electron, then that means it has 36 electrons, just like krypton does. All right, we can generalize this across the periodic table. So from left to right, metals form positive charges equal to their group number. From right to left, nonmetals form negative charges equal to how far they are from the nearest noble gas. The transition metals are a bit less predictable. So for example, copper can form Cu1 plus or Cu2 plus. And iron can form iron with positive 2 charge or iron with a positive 3 charge. So for transition metals, we need to know some additional information to know the charges. So this periodic table highlights the ion charges by group. So groups 1 and 2, they're shown with +1 and +2. Groups 15 through 17 show -3, -2, and -1. And the transition metals are shaded differently to reflect their variable charges. So this helps us to visualize how these ionic charges will vary across the periodic table. So far, we've looked at ions made from single atoms, and these are called monoatomic ions. Now we introduce something called polyatomic ions, and as the name suggests, poly means more than one, mono just means one. So polyatomic ions, these are groups of atoms that are bonded together that carry a net charge. They behave like a single unit in chemical reactions. And an important subclass is the oxyanions, and those contain oxygen atoms, and they're bonded to another element. These are some common polyatomic ions. You don't have to memorize these, but if you choose to continue taking chemistry courses, it might be in your best interest to memorize the names of these polyatomic ions. Hydronium is something that you will need to know for when we get into acids and bases. Also, hydroxide, those both have to do with acid-base reactions. So those are good to know. Carbonate, CO3 to negative is another one that's good to know. And again, if you can, try to memorize all these if you have the time to go through them and know what they are. We'll talk a little bit more about prefixes and suffixes in another part of a lesson as well. Here we have dihydrogen phosphate. So phosphate's PO4 negative, and then we have the dihydrogen. These are just some other examples of common polyatomic ions. Naming oxyanions. This part gets a little bit complicated, but oxyanions, their name is based on the number of oxygen atoms that exist. So if something ends in ATE, that's the suffix, that means that there's more oxygen. So an example would be nitrate, NO3 negative. There's more oxygen there. If it ends in ITE, there's fewer oxygen atoms. Example would be nitrite, and that would be NO2 negative. If there are 4 or more related ions, PER it means the most oxygen or the largest number of oxygens, and hypo means the least number of oxygen atoms that are present. These prefixes and suffixes, they help to distinguish the differences between these polyatomic ions. Let's see here. Types of chemical bonds. There's two types of chemical bonds. One of those types is an ionic bond, and that's where electrostatic forces of attraction are occurring, and that's transferring electrons. So it's taking electrons from one element and it's giving that to another element. Those are ionic bonds. And electrons, when they're shared between two elements and molecules, this is called a covalent bond. Um, Compounds are classified as ionic or molecular. We also say covalent on the basis of the bonds present in them. Covalent bonds form when there's two nonmetals, and ionic bonds form between metals and nonmetals. So the bond type is ultimately going to determine the behavior and the structure of a compound. Metals tend to lose electrons to form cations, so they lose electrons and become positively charged. Nonmetals tend to gain electrons and form anions, and they tend to have more of a negative charge. When metals and nonmetals react with one another, uh, that's when the transfer of electrons takes place, and we start to have ionic compounds. So an ionic compound example is sodium and chlorine. Sodium gives up an electron, it becomes Na plus. Chlorine gains an electron and it becomes Cl negative. And the result is a stable sodium chloride ionic compound. And we just get NaCl, and there's no more plus and there's no more minus charge there. Another example is calcium and chlorine. Calcium gives up two electrons and becomes Ca2 plus, and two chlorine atoms, they each gain one electron. So it forms the ionic compound calcium chloride, so CaCl2. And these examples show us the importance of balancing out charges when we're forming these different compounds. Typical properties of ionic compounds, they include high melting and boiling points. They tend to be solid at room temperature. The ionic compounds don't tend to conduct electricity when they're solids. They do conduct electricity when they're molten or dissolved in water. And these properties result from the strong attraction between oppositely charged ions. So this figure shows that sodium chloride has a melting point of 801 degrees Celsius. So that's quite a bit of heat. When it melts, the ions are free to move and they can conduct electricity. And this highlights the connection between the structure, the phase, and the conductivity in ionic compounds. We have sodium lamps that produce light. This I believe is just a standard light bulb, but we do have lamps that have molten sodium chloride which causes there to be light. Formulas of ionic compounds. Ionic compounds are electrically neutral overall. So although they involve positive and negative ions, when they form a compound, they become electrically neutral. So we want to write a correct formula, we have to balance the total positive and the negative charges. And this does not always result in a 1-to-1 ratio. If we look at Al3 plus and O2 negative, uh, when we combine these, if we just combine them with a 1-to-1 ratio, they would not form an ionic compound. It would still be an imbalance of charges. So instead, we have to multiply the aluminum by 2 and the oxygen by 3. And when we do that, now we have +6 for Al3 plus. So we have a +6 charge when we multiply that by 2. And when we multiply the oxygen by 3, I get this to write on here. Sometimes I can't write on the PowerPoint. When we get the oxygen times 3, then that also gives us a -6. So +6 and -6 gives us this neutral charge as our final ionic compound. This slide shows aluminum oxide, which is what we just found previously in the example. Even though pure aluminum oxide is colorless, there's trace amounts of iron and titanium that give this blue sapphire its color. This is a reminder that even small changes in a chemical composition can lead to significant differences in physical appearances. So many ionic compounds, they contain polyatomic ions. When we're writing these formulas for these ions, we treat the entire polyatomic ion as one unit. We use parentheses when there's more than one of that group is needed. So if we have Ca2 plus and PO43 negative, we would have to use we'd have to group these together in a certain way. So if we say that there's 3 Ca2 plus ions, that's 3 times Ca2 plus, and that gives us a +6. For the PO3 negative, we have to multiply the -3 times 2. And in order to do that, we have to put these parentheses here in order to make that a -6. -6 and +6 cancels out, and this is our final result here. So just to summarize, molecular compounds or covalent compounds, we also call them, is when atoms share electrons. They are with a combination of nonmetals, and they often exist as gases. They have very low boiling points and low melting points. Here are the practice questions for this section.